Satyabama Institute of Science and Technology.
Myself, Dr. M.R. Ebenezar Jebarani, Professor, Department of ECE, Satyabama Institute of Science and Technology, Chennai. In this video lecture, we are going to discuss about 8051 timer programming. I am just taking the application oriented. So, two registers are there to control the timer. Two timers are available, timer 0 and timer 1. Today, I am going to generate a square wave. With the help of this timer, I am using this timer for calculating the delay. So, in this, we are using mode 1 and the timer we are having two SFR, that is nothing but the special function register. One is timer mode register, the other one is timer control register. So, we are having two registers here. We can select which mode the timer can be operated. Either it is in the counter mode or it is in the timer mode. So, that will be decided by C/T bar. So, when it is 0, then it will be acting in the timer mode. Same way, the gate should be low as well as the timer control register. We are having two signals we are going to use. They are TR0, which is timer 0 run control bit, and the other one is nothing but TF0, which is nothing but overflow bit. Whenever the timer count expires, it will be generating a interrupt through this timer overflow. So, for timer 0 it is TF0 and for timer 1 it will be TF1. We are going to discuss only timer 0 today. How to calculate the delay? That is very, very important. We should know that how we are going to calculate the delay. For example, I am just assuming the clock frequency of a microcontroller is 12 megahertz. We are providing a crystal oscillator clock frequency of 12 megahertz here. So, this timer clock input is actually the 12 megahertz, one machine cycle equal to 12 T states. So, we are dividing the 12 megahertz by 12 so that you will get one T state or one clock pulse is equal to 1 megahertz, which is nothing but we are having a clock frequency, a single clock pulse will be 1 megahertz here. So, that means the time taken for a timer to increment one increment, we have to increment one pulse means we need 1 by 1 megahertz, which is nothing but 1 microsecond. Time already you all know that T equal to 1 by F. So, we are calculating T equal to 1 by F is nothing but 1 megahertz. So, we are getting 1 microsecond. So, one clock pulse, the time is 1 microsecond. So, next we are going to calculate the delay of that. So, the delay we are having it as a for x microsecond we are going to calculate the delay. So, the timer we are going to make it as x increment. So, one clock pulse if we are incrementing one increment. So, x clock pulse increment means x pulse you will get the delay. So, 2 power 16 is nothing but because I am going to use 16-bit timer, we are calculating 2 power 16. The total count will be 2 power 16. It will be actually 65,536 in decimal or 64K in hexadecimal. So, in this we are having actually a maximum number of count possible is 16-bit timer we are going to use. So, the TH value and TL value should be loaded with the count. So, the lower will be stored in the lower 8-bit will be stored in TL and the upper 8-bit will be stored in TH. So, here we are going to calculate a value and that value will be a hexadecimal equivalent of the value of 65,536, which is nothing but 2 power 16 value minus what is the delay we needed, that is x plus 1. So, where 65,536 minus x plus 1 is considered in decimal. We have to convert it into hexadecimal because microcontroller, microprocessor, everything the data deal with hexadecimal value. Here we are going to actually start the calculation. So, the initial value to be loaded to the timer register we are going to calculate now. T equal to 1 by F. So, I am going to generate a frequency square wave of frequency 2 kilohertz. So, 1 by 2 kilohertz equal to 500 microseconds. So, the total time duration is 500 microseconds. So, we have to see that in a square wave we are having on time and off time. So, the on time will be 250 microsecond and off time will be 250 microsecond. As it is square wave, the duty cycle will be 50%, okay, as it is square wave. So we'll be having both on time and off time same only. Just divide it 500 microsecond by 2 and you will get on time 250 microsecond and off time also 250 microsecond. So in this we are having actually 250 microsecond, one clock state equal to 1 microsecond. So 250 microsecond divided by 1 microsecond equal to 250 the value. Now we calculated x. What is the formula we had seen? 65, 536 minus x plus 1. What is the x here? 250. So 65, 536 minus 250 plus 1. What is the value we are getting in decimal? 65, 287. So now we are going to convert the decimal value to hexa. As I told earlier, only we have to load the hexadecimal value to the timer. So here we are having 65 287 divided by 16. So we are dividing it by 16. We are getting the quotient as 4080 and we are having the remainder as 7. Next we are dividing the quotient 4080 divided by 16 and we are getting 255 with the remainder equal to 0. Next we are doing 255 which is the quotient of this divided by 16 and we are getting 15 in decimal which is nothing but f in hexadecimal. Same way we are dividing 15 by 16, only you will get f value, okay, because we cannot divide that. So the same value will be stored, that is calculated as the remainder. So now we are getting f. So now we just calculate the value from here to here, reverse order. So F07, that is the value calculated. So for this 65287 decimal, we are getting a hexadecimal value of FF07. Now we will see how to load this value to the timer 0 and how we will getting a delay of this and getting a square wave. This is the program. So first one we are just loading the timer mode register. So what is there in timer mode register? I had displayed there that one in the top most. So we are making the gate 0 and as it is timer, C bar, T bar should be 0. Then we are having the mode. We are selecting mode 1. Mode 1 is nothing but it is in the second diagram 16-bit timer. Mode 1 means 16-bit timer. So we have to load 16-bit data to the timer, low and timer high. Okay, that is there. It is displayed there. So first one we are selecting the mode, timer mode as 01 because we are using this as a timer as well as the gate should be 0 and we are just having the selecting the mode 1. So it will become 01 there. So it is given here. Then for square wave we are having on time and off time. If you are setting the bit of port 1, I am having using the port 1 here of microcontroller. So if you are setting that, you will get the on time, and if you are clearing the bit, you will get the off time. So here we are first setting the bit of port 1.0 because we need only one pin for connecting to the CRO. So P1.0 is connected to the CRO positive and the ground of the CRO will be connected to the ground of the microcontroller. Next we are calling a delay. So in that delay only we are going to load our data what we have calculated. So in this delay, see this will be jumping to here. So in this first we have to load the timer high. So timer high is nothing but the value we calculated is FF07. So what is there here? The timer high is FF. So always your assembler, if it is alphabetical one, we have to prefix with 0. So we are prefix with 0 and we are writing FF here. Then we are loading timer low, that is lower 8-bit, that is nothing but 07. For that we no need to prefix 0 because it is a digit. Then we are setting the timer, we are making the timer to run. So once we loaded, it is decrementing, the timer will be decrementing, and once it reached 0, it will be giving the interrupt. How it will be giving the interrupt? Through TF0, that is timer 0 overflow flag. So we are setting the timer and we are waiting till the TF0 is set to 1. So no bit in TF0 means we have to wait because the counter is decrementing and it is waiting, we are waiting till it reaches the 0. So that it will be generating a delay of 250 microsecond. So it will be waiting in this loop till you are getting the TF0. Once the count reaches 0, your TF0 will be 1. So once it is reached, it will be coming to the next instruction, which is nothing but we have to clear the stop the timer First, initially we had run the timer. Now we stop the timer by giving the bit TR0 to 0 because it is a run control bit. Next one, we are clearing the overflow flag also because again and again it should not create unwanted return. Okay. So after that, we are just returning to the main program. There what we are doing means, again we completed the on-time delay of 250 microsecond. Now we have to generate the off-time delay of 250 microsecond. So for that, we are making the bit low. So that is clearing P 1.0. Initially we made 1 which is on time, and now we made 0 which is the off time of the square wave. So clear P 1.0, and we are calling the same delay which is nothing but it will be generating a time delay off time of 250 microsecond. So same operation repeated for off time also. Once it is again returning to the main program, again and again we need the square wave to be generated continuously. So we are giving jump to main. So again 1 0 1 0 it will be generating the square wave with the delay of on time 250 microsecond, off time 250 microsecond, total t equal to 500 microsecond, which is nothing but 1 by t equal to f, which is 2 kilohertz. So we generated a square wave of 2 kilohertz frequency with the help of this timer in this lecture. So we had seen that the output is displayed here, and how we are that TF0 is generated. With this we are completing the lecture. Thanks for watching.